Integration. First of all, we can compare integration and differentiation. Integration x to the power n dx equal x to the power n plus 1 divided by n plus 1. X to the power n plus 1 divided by n plus 1. In this case, power increases by 1. This is what formula of integration. Integration means adding or summation, and here differentiation ddx of x to the power n equal n dot x to the power n minus 1, and here ddx of x to the power n is equal to n dot x to the power n minus 1. Power decreases by 1, and here for integration power increases by 1, n plus 1 divided by n plus 1, and here power increases by 1, n plus 1, and that enhanced power, increased power will be in the denominator, but here decreased power, unchanged power comes in front of x, and decreased power, that is n minus 1, will be the power of x after differentiation. Integration x cube equal integration x cube dx equal x to the power 4 divided by 4 using the formula. So integration x squared dx equal x cube by 3 x to the power 3 divided by 3. Integration x dx, that is x to the power 1 dx actually, integration x dx equal x square by 2. So here the power of x was 1, now it increases to 2. Now integration dx equal x only. If we integrate dx, then we get x only. So if we explain this formula, integration x to the power 0. So we have to erase this. Integration dx can be written as integration 1 dot dx equal integration x to the power 0 dot dx. 1 means x to the power 0 dx is equal x to the power 0 plus 1 divided by 0 plus 1, which is 0 plus 1 divided by 0 plus 1. From that formula, x to the power n dx, and we get x to the power 1 by 1 means x only. So hence we get integration dx equal x. Integration dx is equal x. Integration dx is equal x. Now we have to discuss few formulae of this chapter, or in connection with integration. So first formula already we have discussed, which is integration n dx equal x to the power n plus 1 divided by n plus 1. There should be dx, integration x to the power n dx, n into dx equal x to the power n plus 1 divided by n plus 1. Then integration c dx, it should be dx, integration x to the power n dx equal x to the power n plus 1 divided by n plus 1. Then integration c x to the power n dx. C is constant, so you can bring c outside integrations. C integration x to the power n dx, where c is a constant. Where c is a constant. Number 3 formula, integration u plus v dx equal integration u dx plus integration v dx. U plus v means some addition of two variables. Number 4 formula is integration u minus v dx. Integration u minus v dx. Not integration sin x dx, it should be integration u minus v dx. That will be same now. Integration sin x dx is minus cos x. Number 5, integration cos x dx equals sin x. Integration cos x dx equals sin x. Number 6 formula is what? Integration dx by x equal log x base e. Log x base e, where we know that from the formula of differentiation ddx of log x base e equal 1 by x. 1 by x. Therefore, d of log x base e, d of log x base e equal dx by x. Dx will move on the right hand side, dx by x. So integrating both sides, we get integration dx by x. Integration dx by x equal integration d bracket open the log x base e. Therefore, integration dx by x, integration dx by x equal log x base e. Integration is what addition and d means splitting. So integration and d will neutralize and we get only log x base e. So finally we get integration dx by x as log x base e or ln x. Now we have to move to the next formula. Next formula is number 7 formula in connection with integration is what? Integration ex dx is equal to only e to the power x. Integration ex dx is equal to e to the power x, where e to the power x is exponential x. There will be no change in integration over e to the power x. Now application of integration in physics. So here number 1, the instantaneous velocity. The instantaneous velocity of a body at an instant t second is given by instantaneous velocity of a body is given by v equal to ds by dt. ds means small change in displacement and dt is small change in time. ds by dt. So or ds equal v dt. ds equal small change in displacement is ds equal v dt. Integrating both sides, integration ds equal integration v dt. Integration ds is s, therefore s is equal integration v dt. So we get the expression of displacement in terms of velocity. S is equal integration v dt. Displacement is equal integration of velocity over time. This is what we get the expression of displacement from the expression of velocity. So if we want to find displacement from velocity, we have to use integration. This is displacement. S is equal integration v dt. And ds is small change in displacement, and if we differentiate displacement we get velocity. Now if we integrate velocity over time, then we get displacement. Now we have to erase this part to write down the next concept in connection with the application of integration in physics. Number 2, the instantaneous acceleration of a body in an instant t-second is given by the instantaneous acceleration. The instantaneous acceleration of a body is given by A equal dv by dt. dv is small change in velocity and dt is small interval of time. A equal dv by dt. Therefore, dv equal a dt. dv equal a dt. Integrating both sides, we get integrating both sides. Integrating both sides, we get integration dv equal integration a dt equal integration a dt. Now we know that integration dv is v, that is instantaneous velocity. Therefore, v equal integration a dt. This is what the expression of integration a dt. If we integrate acceleration over time, then we get instantaneous velocity. This is instantaneous velocity. So we can find the expression of instantaneous velocity from acceleration. For that you have to use integration. Instantaneous velocity. Now we can compare the formula of integration differentiation in connection with the application of integration in physics. V is ds by dt, then S is equal to integration v dt. Integration v dt. That means from displacement we can find velocity v equal to ds by dt. But and also from velocity we can find displacement. So therefore v equal to ddt of s. ddt of s. v equal to ddt of s. And here s is equal to integration v dt. That means from velocity we can find displacement also. If we want to find acceleration from velocity, then we have to differentiate velocity with respect to time. So a equal to dv by dt. Therefore a equal ddt of v. ddt of v. That means instantaneous acceleration. If we differentiate velocity with respect to time, we get instantaneous acceleration. Similarly, velocity v equal to integration A dt. Integration A dt. V equal to integration A dt. So V equal ds by dt and S is equal integration V dt. So if we want to find acceleration from velocity, that means velocity to acceleration, that is in forward direction or forward process, acceleration can be derived from velocity. We have to use differentiation. Differentiation. And if we want to find velocity from acceleration, that is the reverse process. Velocity from acceleration, that is the reverse process. We have to use integration. To find velocity from acceleration, and that is the reverse process. Differentiation means splitting and integration means adding or summation. So velocity will be obtained if we use integration over acceleration. Velocity. So from velocity to acceleration, differentiation is used, and to find velocity from acceleration, integration is used. So from displacement to find velocity, V equal ddt of S, and from velocity to displacement we have to use integration.